Hi, and welcome to part 3 of flow tectonics and how to predict earthquakes. When it's summertime in the northern hemisphere, it's wintertime in the southern hemisphere. So, conversely, when it's summertime here in the southern hemisphere, it's wintertime in the northern hemisphere. So if you're looking at a season like a hurricane season or a tornado season, or in this case an earthquake season, when the southern hemisphere is in summertime, it is expanding more in comparison, kind of pressing up. Meanwhile, in the northern hemisphere, it's wintertime, so it'll be contracting as the crust is being cooled by the wintertime conditions via the tilt of the sun. And so between this push and this pull, we tend to see large earthquakes in the January months, typically. Conversely, when this is contracting and this is expanding, it tends to stop the conveyor belt. So you have less earthquakes in July than in January, typically. Springtime, within a range. Also, system loading. Due to the thermal loading of the planet, its overall heat load, when you increase the atmosphere's insulative effect by changing its composition, its R value changes, becomes greater or lesser. It loads the planet with heat energy based on how much it's retaining and how fast the storms can remove that. But we look at big system events, so like Haiti moved this way, because like I said previously, it tends to go up this way as it meets the Pacific plate and is ground and shoved up this way in a swirl of mountain ranges. But so since you're looking at the overall system, you can say if it's affecting here, how would it affect here? Or if it's affecting here in Australia and New Zealand, what can we expect as far as a push? What can we expect for it to load the other areas of the plate? Wherever you have a push, you're going to have a pull, or it's going to load somewhere else on the planet. Needless to say, the trenches are typically endpoints in the crustal equation, and when you have significant events here, you can minus it from the loading system of stresses on the planet when you're doing a stress analysis, or at least a rough stress analysis of how the structure is being stressed. So we've seen Haiti occur, we've seen West Virginia a few years ago, we've seen a lot in China. Because it's interesting, according to flow tectonics, the Australian flow goes up this way, where it gloms onto here and then pushes over. The African continental movement comes over here till it's India, and when these two meet, this will oppose the motion of that, as they both press up on the landmass here. So since this stops this, it has nowhere to go. It's up and in, which is why you have the Himalayas here. Meanwhile, this is burning and churning over this way, and that then gives you your typical Chinese earthquakes activity that you've been having. So if we track where things are happening, especially the large earthquakes, we can start to see a stress pattern It's almost like being on a conveyor belt and watching it chatter. You know it's going to chatter every so often over here while it whirls over here, depending on the type of fault or bearing that it's going on, whether it's horizontal, vertical, tilted. So we can keep track of our events and say that according to our stress analysis, if these areas are registering recently here, it's going to load this area and this area, and we can expect some type of movement to transfer the stress from this region to this region. Also, following the movement of the flow of the plates, or the plates of flow. And so in this way, we can hear the routine noises of the Earth that you can typically expect as the Earth moves. So when I get some better numbers, have more time to make good graphics and whip up some statistical formulas, among all the other things I try to do in a day, I'll present those. But that's the basic idea. I hope you liked it, and if you have any questions, contact me at d.h.perio, P-E-R-I-O, @juno.com. And any questions, or what about this? On all these things, there's things I wish I hadn't said, but I'm sure you get it. So, till next time, see you later.